This is an introduction to tuples and dictionaries in Python. Tuples are like lists, but they're immutable, which means the values stored in a tuple can't be changed. Lists can do that. And tuples are created with parentheses instead of with brackets. We still access the elements of a tuple with square brackets, but we create them with parentheses. So we'll see that with lists we use parentheses to create the list. With tuples lists use square brackets for creation, tuples use parentheses for creation, and dictionaries will use curly braces for creation. But all three use square brackets when accessing the elements. If we try to change an element of a tuple, like T1 is 55, we'll get an error because tuples are immutable. So here's an example of creating a tuple. We use a comma-separated list of values between parentheses, like so. If we want to create a tuple with only a single element, like T equals 1.1, then we need to add a comma at the end so that it interprets it as a tuple instead of just a number surrounded by parentheses. So this is a tuple, and this is just a regular T is 1.1. It is possible to put a trailing comma. That's fine for consistency, but it's not required. Okay. One of the primary areas where we use tuples is for packing and unpacking operations, so multiple assignment. So if we have a tuple T is 1, 2.5 minus 3, then we can unpack this tuple in at least 4 different ways. We can write x comma y comma z equals t, and this will take the 3 elements and unpack them into x is 1, y is 2.5, z is minus 3. We can either do that by assigning t to a tuple and then x, y, z equals t, or we can do it directly. X, y, z equals 1, 2.5 minus 3. That gives the same thing. We can put parentheses if we like. X, y, z surrounded in parentheses equals t. That will also unpack. And we can put the parentheses around both sides if we're doing it explicitly. So parentheses are basically optional on either side. And in each case, we're assigning a set of variables to the elements of the tuple. Let's see. So here we can see once we print these, we have the different values that we're assigning to, and that's just extra. So x, y, and z, 1, 2.5 minus 3. We used this when we were dealing with functions, when we were returning more than one thing from a function. So if we have a function add and multiply x comma y, and we return x plus y and x times y, and then when we call this function add and multiply, this is a tuple containing 2 elements, and we're assigning it to s and p. So s will have x and y, and p will have x times y. So this whole quantity, this is one quantity. It's a tuple that has 2 elements, x plus y and x times y, and we unpack it into these 2 variables in the same way that we did previously. We're just not doing it quite as simply. We're using it in the way that we return from a function is the tuple, and we assign to the return statement we're unpacking. Conversely, you could go t is add and multiply, and then this single tuple is now stored in a single variable, which is a tuple, and then we can access the elements of that tuple. So if we go t0 and t1, then we get, oops, need to run NumPy clearly. Let's go back. Well, maybe I have it. It's okay. We'll just import NumPy explicitly. import numpy as np. And then when we print these two, we have s and p, and t0 and t1 give us the same thing. Okay. So that's tuples. Brief introduction. Let's look at dictionaries. Dictionaries are like lists, but they're created with curly braces instead of square braces. And where lists use integers as the index, dictionaries you have an explicit key instead of an integer. So in creating a dictionary, we use a comma-separated list of key value pairs. And then when we access elements, instead of doing bracket 0, bracket 1, bracket 2, etc., we use bracket whatever the key values were that we created. So below we're going to use strings as the key, but they can really be any type. And this link here will provide some more information on dictionaries. So here's an example. We have a list of species molecular weights. Well, here we're making a dictionary of species molecular weights. So curly braces. And then a comma-separated list of key value pairs. And I put these on separate lines just for convenience in looking at it. So here we're mapping CO2, the string CO2, to the value of its molecular weight, H2O, its value, O2, its value. And then to access the elements, we would do molecular weight bracket, a key, O2, and that will return the value. So in this case, molecular weight of O2 is 31.998. Okay. So if we were just using a list, then we would use something like molecular weight 0, 1, 2. But with a dictionary, we can be more explicit, and now we know exactly what we're talking about because O2 is more descriptive than 0, 1, 2 in this, if it were a list. You can map anything to anything else. So here we have np.sign mapped to what up sign, and np.log10 is mapped to np.tanh. So if we go funcs, our dictionary, bracket the key, np.log10, then this whole quantity is np.tanh. And because np.tanh is a function, we can go parentheses 22, because it's fine to go function parenthesis 22. That's how we call a function. Of course, you wouldn't want to do this. That's a terrible thing to do. But if you want to obfuscate your code, then redefine everything, and then log10 will return something like tanh. Okay. There's several useful functions with dictionaries. Molecular weight. If molecular weight's a dictionary, we can do mw.keys, .values, .items, and we can also find the length using our friend the len function. So here's a use case of keys. It's not uncommon to want to loop over the elements of a dictionary. So mw.keys, we can think of it as a list of the keys that are in the dictionary. So if we do 4k in mw.keys and then print k, then it will print out in sequence the different keys. Because we have the keys, we can also access the elements of molecular weight by the key. So mw.k, mw bracket k will give the corresponding values. So pretty standard form here for k in keys. There is values. For v in values, print v, and then you can access the values in the molecular weight array. And MW for comparison, 44, 18, 31, 28 are the values given. And finally, the third one is the items. So items will give a list of tuples where each tuple is the key and the value. So if we do, let's look at that, mw.items, it's type dict items, and then you can see that it's a list of tuples where each tuple is a key value. The first element of the tuple is the key, the second is the value. So here, when we do for kv, we're effectively expanding, unpacking this tuple into k and then into v. And then when we go to the next item, we unpack H2O into the key and 18 into the value, etc. So here we can, when we print it, we get the key and the value separately. And that can be convenient when you want to use both of these. Okay. Items. Okay. Okay, we can check to see if there happens to be a key in our dictionary. So if H2 in MW, if MW is a dictionary, then this statement will return a true or a false. If it's true, then H was there, and if it's false, it wasn't there. And we can see when we print MW that in fact there is no H2. So when we run the code, H2 is not there. That's what we get. We can add items to a dictionary by simply putting a new key in. So if we have something like MW, the top line is what we currently have. If we go MWH2 is put in a value, then you're effectively adding a new entry to the dictionary. H2 is the key, and that's the value. So pretty straightforward. You just assign to it as if it was there, and if it's not there, it'll put the new quantity in. If it is there, you'll be changing the value of the corresponding key. So before, set a new thing, and after, and we can see after, put in H2. Okay, we can delete items from a dictionary by using the del, and then the molecular in MW, the key, and that'll delete an element from the dictionary. You can also pop some key, will also delete the element, and you can use pop item, which will delete the last inserted item. So if we start with molecular weight, it now has H2 because we added it before. If we pop item and then print it, then H2 is gone off the end. Okay, and that's it. So a brief introduction to tuples and dictionaries in Python.